Hi, I'm David. In this diagnostic module, we'll show you how to locate a high-speed bus short to ground or short to voltage. High-speed bus faults are not that common, so you need an easy and efficient way to locate them. This module is designed to give you those skills. This is the schematic for our vehicle that has a no-start complaint. As you can see, there are 9 modules on the high-speed bus, all connected by twisted pair wiring and going to pins 6 and 14 on the DLC. Before doing any diagnosis, always remember, check the battery voltage. Modules will not be able to communicate if they don't have the correct voltage. If the voltage is low, charge and load test the battery before proceeding. We can use a scan tool to determine which modules we're communicating with. And I've found that I'm not communicating with any of the high-speed modules. A short to ground or a short to voltage can occur in any one of the modules or anywhere along the wiring. A resistance check is now done between terminals 6 and 14 on the DLC. Remember, the bus has to be asleep to get an accurate measurement. I'll check the bus is asleep by measuring the voltage on pins 6 and 14. The bus is asleep, so I'll check the resistance. I have approximately 60 ohms. This is the correct reading, so I need to investigate further. I can now check for a short to ground or short to voltage. I'll check for a short to ground between pins 6 and 16 and pins 14 and 16. If I see a voltage, I must have a short to ground on that pin. If there's no short to ground, I'll check for a short to voltage between pins 4 and 6 and 4 and 14. If I see a voltage there, I'll have a short to voltage. I've found it's a short to ground, so now it's an elimination process. Referring to the schematic, I'm looking for a place to split the bus in half. Connector CA230 would be the best spot. Once this is disconnected, the DLC check is repeated. If the fault is still there, then it must be on the DLC side of the connector. And if it's gone, it will be on the other side. Let's check on the vehicle. I've unplugged connector CA230 and the short to ground is gone. This has now eliminated 5 of the modules on the bus. I'll plug the connector back in to return the faulty reading to the DLC. Back to the schematic. I'll follow the bus to the next connector, CA10. Unplug the connector and recheck at the DLC. If the fault is now gone, then it must be in the remainder of the circuit. If the fault is still there, you would need to disconnect CA431. If the fault remains, then it will be in the wiring between CA230, CA10 and CA431. If the fault disappears, reconnect CA431 and disconnect the driver's seat module. If the fault remains, then it will be in the wiring between the driver's seat module and CA431. And if it's gone, the fault will be in the driver's seat module. I've unplugged CA10 and I'll recheck my reading at the DLC. And it shows that the fault is gone, so it must be in the remainder of the circuit. The next connector is the transmission control module. Unplug the module and recheck at the DLC. If the fault is still there, then the fault will be between CA10 and the transmission control module. If the fault is now gone, then it must be in the module or the remainder of the circuit. To check the module, measure the resistance between connector JB230 terminal 5 and a module ground, as well as between terminal 6 and a module ground. If a fault is not found, then reconnect the module. There are now only 2 modules and 1 connector left. From this point, it doesn't matter which module you choose. They're both connected in parallel. I'll pick the easiest one, which is the engine control module. With the engine control module disconnected, the fault disappears. That means that the engine control module has an internal short to ground. If the fault is still there, I could move on and disconnect the Dynamic Stability Control module. If this module was okay, the fault would have to be in the wiring. There is one last connector. JB1 could isolate the wiring to the ECM. That's the procedure for finding a short to ground or short to voltage in a high-speed bus. Following a logical sequence of elimination is the most efficient way to find the fault. And don't forget to watch our other 2 modules on high-speed CAN diagnosis. And always remember, training is the key to your success. Bye for now.